Hi.
Good morning, everyone. So I'm Jonathan Rocolo, and I will be your speaker, your presenter for today's webinar. So quickly, the agenda for today, I would like to present you. So I will start with a quick introduction about JFrog, just for the people who don't know us for now. I'm sure you know us, but just in case, I will take a few minutes also to give you a quick overview of the JFrog platform, what it means, what are the different services and components, and what we want to, where we want to help you, and how we want to help you in your journey. And after this, let's say, high-level overview, I would like to go back to the basics and talk a bit more about development lifecycle with a quick focus regarding C++ development lifecycle challenges. And then we'll talk about binary repository. What is it exactly? Why do we need it? And what is JFrog Artifactory in this area? How it can be used for C++, but other challenges, other package types within your company, within your organization. And after explaining some concepts, I will take some minutes to show you a quick demo of all the things I will explain. And we should have some additional minutes to address some questions. If I don't have time to answer all the questions, or if I'm not sure for being able to provide you a clear answer, no worries, we'll address those questions offline with follow-up email. So feel free, as Nera said, to ask any question in the question box. So let's start with a quick introduction about JFrog. So JFrog, as you may know, is an Israeli company founded in 2008. Now we have offices all over the world, in the US, in India, in China, in Japan, in Europe, and Israel, of course. We are more than 500 employees in all those offices, and we have more than 5,600 paying customers for now. Paying customers because we have also community and open source edition of our products. So, but we know we have this base of paying customers. What is interesting is that part of those customers, we have almost any kind of companies, and we are proud to have 70% of the Fortune 100 companies as part of our customer. We have an interesting growth with almost 150 new enterprise customers monthly coming to use our products. And we are also interesting statistics, so growth in terms of AR, but also in terms of usage of our products. We know, for example, that today we have 2 billion dependencies downloaded per month from our Bintray distribution platform. And around 3 million enterprise developers are using on a daily basis our products. We are also community champions, and we are involved a lot with different community. So if you're here, I guess you're familiar with Conan, and you know that Conan is part of JFrog. You might know also that we are hosting and managing Conan Center at JFrog, so for the C++ community and Conan community. But we are also involved with Go community. For example, we are managing and hosting Go Center, which is a center for Go modules. We released recently, last month, I think, Chart Center, which is the first central repository for Helm charts with security analysis. And we are, for a long time, also involved with community for Java and other package type with Bintray. Last but not least, we are considered as DevOps unicorn. because DevOps is really the area where we are involved. These slides show you a short list of our customers. What is interesting here is not so much the name, even if it's interesting to see famous names like Google or Oracle, NASA, and so on. But what interests me is that we have customers in almost any industry area. And this is a thing that is very interesting for me, is to see how the DevOps and this software development revolution or evolution is embracing all the industry area. So you have the, let's say, the cool kids that are, of course, in this area, like Google, Amazon, and that are pioneer in the DevOps world. But it's interesting to see that even companies that are pure retail company like Walgreens, Target, are also heavily involved in this DevOps transformation and trying to modernize their software delivery lifecycle toolchain. At JFrog, and why we are so successful, I believe, is because of our approach, which is from the beginning unified and universal approach. First of all our products are built in a universal, with a goal to provide universal support, which means that we started with Artifactory as a universal binary manager, which means that it supports many package types, not only Java or Docker, but we are supporting more than 25 package types for today. But we are also universal in this way you can integrate Artifactory with the ecosystem. We have integration with more than 50 technology partners. You can integrate our products with most of the tools you already have in your toolchain, such as CI servers, code analysis tools, and anything you can find in this kind of toolchain. We provide hybrid and multi-cloud support also, which means that all our product can be installed on-premise, on the cloud, any kind of cloud, but you can also go with SaaS offer provided by JFrog, running your JFrog platform on our SaaS, or you can also go with hybrid solution with a combination of your own private cloud, on-premise, and SaaS offers. We provide continuous security along the tool chain. We have a dedicated tool for that called JFrog X-Ray that allows you to scan and give analysis and report from the beginning of your toolchain when you start to consume external packages to the end of the toolchain when you distribute to the runtime your releases. And all the products we built are built in a fashion that can be highly available, allowing you to have horizontal or vertical scaling to scale whatever the needs you have regarding your business. So what we have in the JFrog platform today, I guess some of you are familiar with the first product, Artifactory, that we can see on the left of this diagram. Artifactory is our flagship product at JFrog. This is the one we built and we built the company on. And all the products are using Artifactory for access authentication and other integration. This is really the base of the JFrog platform. So Artifactory is our universal package manager, and the idea with it is to be able to manage your artifacts you consume from third-party repositories, artifacts you produce, and to track them with all their metadata. So This is really where you start to manage binaries and not only code. The second product we have in the platform is called JFrog X-Ray. It's a security and license analysis tool. The idea with X-Ray is to be able to scan any binary stored in Artifactory and to give you a result regarding, first of all, its recursive analysis, showing you all embedded binaries within your own components, but also to give you reports and analysis regarding known CVEs and license information. X-Ray allows you also to automate things, policies you want to apply when you detect something wrong, like a new CVE or license that you don't want to have in your product. On the right side of JFrog X-Ray, you can see distribution, JFrog distribution. This is a service we released 2 years ago now. And distribution, the main idea here is to be able to ship in a secure, atomic, and immutable way your releases to production time, to production sites. What I mean by production site is to ship your binaries, your releases, as close as possible to the final consumer, to what we call the edges. And for that, we also release the JFrog Edge nodes components, which are kind of very light Artifactory for read-only to provision edges that can be Kubernetes cluster if you are managing your own runtime, but it can be also your final consumers, like your own customers for delivery purpose, or it can be your data center, any places where you want to consume final releases and you want to make sure those releases, this set of packages, are shipped together in an atomic and immutable way. At the bottom of the diagram, you can see JFrog pipelines. This is a last kid from JFrog. It came from the acquisition of Shippable. And it's a declarative CI/CD tool that covers and allows you to automate the entire tool chain from code repository to the runtime. It integrates, obviously, with all JFrog tools. So you have integration with all the JFrog products, but also with most of DevOps tools in general. So you can integrate JFrog pipelines with your existing CI servers, such as Jenkins, or with your Jira, with a Kubernetes cluster, or any kind of tool you already have in your organization. Last but not least, on the top of my diagram, you can see mission control and insights. Mission control is a central dashboard to control and monitor all the JFrog tools along your toolchain. Insights, that is part of mission control, is in charge of gathering metrics and give you tendencies across the different tools in your toolchain. So the main idea with it is to enable what we call data-driven DevOps and to get feedback flow from the toolchain. As you can see with this platform, and this is the main goal we have at JFrog, we want to cover the entire space or gap that is between the code repository, let's say your Git, and the runtime. And with this set of tools, we are covering the build, the testing, release, and deployment phase, but we are not managing the runtime yet or code repository. So let's go back a minute to something more, let's say, basics or day-to-day work. And let's talk a bit about development lifecycle and what it means. The main purpose when you are doing development and when you are building software is to release this software at some time and to run it in some runtime. With the evolution of software management during the past decades, let's say, with the agility, then the DevOps and all these nice practices we built, we all agree that we need iterative and continuous improvements in our processes. This is why this kind of diagram is quite common, and the idea is always the same. When you are building a tool chain, you start by coding in your own language. You build your code to generate some artifact binaries that will be tested, released, distributed to the edge, deployed to a runtime environment, and based on monitoring, on metrics, you will learn, get some knowledge, and you will code again and make your software better. This is the main idea. If you look in the timeline of this iterative process, it's always the same. You start by some source code. So in fact, you start by source code and consuming dependencies, because source code relies on what you are using as dependencies. There are only few projects today that starts fully from scratch. So the first thing a developer does in a company when he is writing software is to write its own code, to choose dependencies he wants to use. And then at the build time, he will generate some artifacts and will deploy them somewhere. This is basically what a developer is focusing on. And it's pretty simple, it's pretty straightforward. Few weeks ago, we gave our first Conan training for C++ people who want to use Conan. It was called Conan Days, and there was full days of training. It happened remotely, but I think it was very interesting. I guess some of you were part of those training days. If you were not part of it, the good news is that we will have another training day, other training classes that will happen in the future. We will send you some information in the follow-up email, I guess, if you're interested. But in a nutshell, what we did during this training day is, first of all, to show that in C and C++ world, development lifecycle is not so trivial and so easy. This is the kind of diagram we had at the end of the training for managing a full project. And I will try to give a quick summary of what we did during this training, but I really encourage you to have a look for the next Conan days and to see and go to the hands-on and to build this training step by step. During the training, we built a very simple application with a graph of dependencies that you can see on the left of the diagram. So there were some libraries, A, B, C, D, and two different applications with different component graph for each application. And the use case was the following. We had the developer working on a particular library, the library B, on this graph, and working on a new feature within a feature branch. We show how you can automate the tool chain on a commit on its feature branch, how to test it, and then after merging the pull request, how Conan were used to, first of all, get this component graph and know that this change on the library B will need to rebuild a set of libraries. In my case, library D and the application 1, the product package. And based on this component graph, we will be able to first run in parallel builds that we were able to run in parallel. And we were able also to, after creating the product package, to store it in a repository manager, but moreover to generate the log file for this particular package, for this particular build. This log file used to then guarantee immutability of this particular build. I will show you this log file during the demo, just for people who missed it. But the main idea here is that during the training, we stored this particular file in a Conan metadata repository. And this file gives you the exact component graph that were used at the build time of a particular Conan package. Last but not least, during the training, what we did is to use the product package to and the log file to install this application, deploy it, and generate then a Debian package that we stored in Artifactory. And this is more or less where I will start my demo later on. So during this training, we used a bit Artifactory. In the background, we explained a bit about it, but we focused mainly on Conan itself and C++. But in terms of binary management, if you are speaking about Conan, you have to understand that Conan is relying on package type. Conan is a package type, and at some point you need to store those packages. And what can you do to store those packages, to share it within your organization? You can use a shared file space, so an FTP, basically. This is what people used to do in the past, not with Conan, but with tools like Maven, for example, where you can rely on a pure layout and it can work to some extent. But when you start to have a specific protocol, such as with Conan, or with other technology like Docker or NuGet, and you start to have this protocol, an API, how you will handle it. This is the first thing. So how you will expose API and all the logic needed to fetch the right dependencies and so on. Another alternative, and I'm sure many people here did it in the past or are still doing it, I did it in the past, is to use your VCS, your Git repo, your SVN, whatever, to store your binaries, the result of your build. The thing is, first of all, VCS are not built for that. VCS are called code, source code management. So it's for code, it's not for binaries. And why? It's first of all because the main idea with a VCS is to be able to diff text, to merge them, to compare different versions of a file, which is not doable at binary level. There are other reasons why you don't want to do that, for indexation issues, but the main thing is that the VCS is not built to do that. Also, if you look at the underlying mechanism in a VCS like Git, the versioning is not built to store binaries. It's stored by content, not by name. And the idea with binaries is different from code. In code, you want to check the diff. You want to be able to go back in time, while in binary, you want to be able to track, to version, and to keep immutability of your binaries. So the conclusion is quite obvious, but this is why we built binary management tools. And today it's maybe obvious to say that, but believe me, 10 years ago it was not. So what can you do to store binaries is to use a binary management tool. And if you look at binary management tool, there are plenty of solutions on the market. But if you look at what you want, first of all, you want some functionality. So if you work with Conan, for example, you want to have a binary manager that will work with Conan. That's pretty obvious. You want security. You want to be able to control who can access to what binary, what package within your binary manager, binary management tool. But you want also to be able to track who accessed, who produced which binary, who downloaded which binary, and so on. And moreover, you want to have availability. At the time you start to build automation and toolchain using a binary repository manager, this binary repository manager starts to be the backend of your toolchain, which means that it's also a point of failure for your toolchain. And if your delivery process, your engineers are relying on your toolchain, losing this binary manager or having downtime on it means that you will have downtime on your entire toolchain and your delivery process, which is not suitable for your business. So, in terms of functionality, if I look at more enterprise-grade level, I want to be able to have control on my storage. I want to be able to scale in time because I know that I'm producing binaries every day, and so this storage will increase every day. I want to have performance and not to be impacted because my storage is growing. I don't want to have an impact on my performance. I want to be able to address different technologies because even if I'm a C++ engineer working with Conan, and because I went to the Conan days, I know that I'll need at least some generic repositories. But if I want to address also the delivery parts, I might need some Debian repositories or RPM repositories or Docker repositories, something from another flavor that is more suitable for deployment and runtime. I want to be able to manage version and updates, to have easy maintenance and administration. In terms of security, I want to be able to authenticate and give authorization to my people, to keep integrity and traceability of my artifacts, basically who's doing what, and making sure that crucial information are kept forever, or at least for the time I need them. And as I said, I want availability and performance. I want to be able to have my local toolchain with no downtime, but I want also to have a distributed team working with good performance. So what about when I have engineers spread across the globe for my organization? How can I make sure they will have all the same performance and same availability and SLA? I want to have HA and DR. I don't want to lose data. I want to have no downtime once again. And caching, this is for the performance. And one of the solution you can find, and I truly advise you to have a look to it. This is the main purpose for today. It's JFrog Artifactory. And why JFrog Artifactory is a good fit for all of those challenges? It's first of all because JFrog Artifactory provides an advanced storage solution. First of all, in JFrog Artifactory, you can really choose which storage provider you want to use. You can use a local file system or an NFS. You can store your binaries as blob in a database. You can use object storage on Amazon, Azure, or GCP, or even any implementation of S3 protocol for on-premise object storage. You can chain different providers. You can use local caching when you have low performance storage system. You can use sharding, implement redundancy across different shards, across different data centers. And it's really flexible and advanced in terms of what you can do in terms of storage, both in performance, stability, and reliability. Artifactory itself is, as I said, a universal binary repository manager, which means that you can store all kinds of artifacts and resolve all kinds of dependencies from there. You can use it as a proxy or remote repository, and it integrates with all native package manager. We have also integration with most CI servers that exist, like Jenkins, Bamboo, Bitbucket, Azure DevOps Platform, and of course our JFrog pipelines. And the main idea, as I said, is that using Artifactory as your binary manager with its metadata system, you can really use it as a backend for your toolchain and consider it as a single source of truth for your binaries. Very quickly, I said it, you can store more than 25 packages in Artifactory and also generic packages. So in fact, any kind of binaries, even MP4, pictures, documentation, Conan packages, of course, and so on. So in Artifactory, as I said, you can store any kind of binaries, but more important with all those binaries is also to store all the metadata, build results, the context of your build, what happened, when it happened, did I check and tested this library. So this is where you can start to really use Artifactory to both store your binaries, but also track the lifecycle of those binaries along your toolchain. I said it's integrated with most binaries, and let's have a very quick look to Artifactory main components. So I will go pretty fast on this one. Just keep in mind, Artifactory is available through HTTP, HTTPS. There are 3 ways to communicate with Artifactory: through the UI, through WebDAV, there are still some company using it, or REST API. Keep in mind that even when you go through the UI, behind the scene, Artifactory is using REST API to communicate with its backend. What does it mean? It means that you can do everything in Artifactory through the REST API. And we know by statistics that more than 90% of the use of Artifactory is done through REST API. Then in Artifactory, you will find a caching layer for performances and the core concept, which is a virtual file system of Artifactory. Virtual file system because it's divided in 2 parts. The binary store, I mentioned before, this is where you specify if you want to use object storage, sharding, the local file system or whatever. And the second part is the database. Database that will contain all metadata. And here we'll take just 1 minute to give a bit more information about Artifactory and how Artifactory stores artifacts. When you deploy a file in Artifactory, Artifactory calculates its checksum and will store it in your file store, so in your S3 bucket or your local file system, based on its checksum. So here I deployed a file with a checksum that starts with 2EFC blah, blah, blah. And so this file will be stored in a folder starting with 2e under the name equal to its SHA-1. And this is the actual binary on my file system. In the database, I have a table called nodes that contain references to all occurrences of this file in my Artifactory. So here I have a record that says that my file with the checksum 2efc and so on is stored in the repository libs release local under this path, and it's a jar file. What does it mean? It means that if I have the same file with the same checksum, even with a different name, stored in a different repository or different path under the same repository, I won't have a duplicate data, a duplicate binary on my file system, which means optimization of the file system. Okay. So this is one of the first advantage of this checksum-based storage is deduplication of files. For Conan packages, those are small, but when you start to play with promotion and having them in several places, it can be interesting. When we start to talk about Docker images, Docker images are a good example. It starts to be even more interesting in terms of storage optimization. One very interesting thing also is that copy and move operation are very cheap on Artifactory, because when you copy a file from one repo to another one, at the end it's just a new record inserted in the database. Deletion also are just a database operation, and then there is a garbage collection in Artifactory that will delete unreferenced file from the file system, but the delete operation that you are doing as a user is something very fast that is just on the database level. And also with checksum-based storage, we do not need any lock at file level, which means uploads, downloads operation are very fast. And all replication, I will explain a bit what are replication, are checksum-based. So we avoid to send files that already exist on the network. And this provides better performance for the file system because of the non-locking, stability in terms of for the searches, and performances because all searches are database searches, not file system searches. Okay. So as I said, in the database, you have all the metadata, all the information stored about your artifact. So it can be build information, it's calculated metadata from the package, revision number, version number, and so on, but also custom metadata, properties, everything you want to add to your binaries. By default, Artifactory is using the Derby database. Just keep in mind, this is only for small, medium installation. When you go at company level, you should consider using another database, and we support any relational database such as Postgres, MySQL, and so on. As I said, Artifactory supports REST API for everything. We have also a CLI tool that will be shown during the demo very quickly. Keep in mind the CLI is just a wrapper for the REST API, optimized wrapper, which means that you can do parallel requests, multi-threading, and you have some logic implemented in the CLI, but at the end the CLI is just using REST API. We have plugins for CI. We have also the capacity to add user plugins within Artifactory to implement your own logic, your own features if you want to implement some workflow and processes within Artifactory. And metadata are very important. You will see why in the demo. Last but not least, some points when you should think about enterprise grade repository. As I said, Artifactory is built to be universal and agnostic for deployment, which means that you can deploy it on Kubernetes. We have official Helm chart for that. You can deploy it on VM, on Windows, on Unix, on your Mac. You can install it with Brew, with Debian packages, RPM packages. We support multi-cloud, multi-OS. It's really, the goal is to be universal and agnostic. We have hybrid model. We support replication and multi-site topology. This is when you start to have people in different locations, as I said before, and to give them same experience and performances. And all our products support HA deployment, which are pure active deployments, which means that all nodes within a cluster, within an Artifactory cluster, can serve download, upload requests in the same way. And distribution is last point, as I say, to the edge. This is, I forgot I added this point because it will be released very soon. We announced it a few weeks ago during our user conference, but something very exciting for people with massive deployments. We are releasing a peer-to-peer download capacity on Artifactory to also increase performances when you have massive edges or endpoints to upgrade in parallel. Okay. And I think I spoke a lot about the slides, and now it's time to show you a quick demo to go further after the Conan days, as I say. So I'm going to share my screen first of all. Okay, so application, and I'm going to start with a terminal. So you might be able to see my screen. I hope it's big enough. And I will start from almost where we stopped during the Conan days training. So for the people who were there, what we did after building the application is to use AQL. AQL means Artifactory Query Language, and the CLI to find the right Conan package to ship as part of our release. So here I have a file spec. It's a JSON file that can be consumed by the JFrog CLI. And this file spec is simply using an Artifactory Query Language statement to find all items from a particular repository Conan metadata. And the files I want to find are log file, so Conan log files, produced by a particular build, so a build with this name and this number, and with a property profile equal to release GCC 6. So running these commands allows me to find the right file spec, and this is what we did during the training. We use the JFrog CLI as it to download the file spec. And here, after that, what we did is simply to run a Conan install command to install the application. We tested it, and then we have generated a Debian package called app Debian, if I remember. We deployed it in Artifactory. We tested it, and what we did was a promotion of this artifact to a qualified repository. So now at this stage, what we have in Artifactory is a Debian package deployed that contains our application. And we have also a particular object for this Debian package, a build information object, so a set of metadata that reference the Debian package as a generated artifact, and the Conan log file as a dependency of the build. And why I'm talking about that, because for today, I will show you how to navigate in the other way around. So first of all, I will go to another folder on my machine here, and I will show you another file spec, which is a bit different from the previous one. The previous one, we were starting from the Conan log file, so we knew that we had a Conan log file produced by a particular project with a particular number. Now I want to do the other way around. I know that I have somewhere a build Debian app with a particular number, and I know that this build is using a particular dependency, a particular Conan package, and I want to find it. Sorry, a particular Conan log file, and I want to find it to be able to retrieve my Conan package and test it. So here I have this file spec, which is using, again, AQL. And you can see it's a bit different because with AQL, which is a very powerful tool, you can navigate in all properties and entities stored in Artifactory. And here I'm saying I want to find also in Conan metadata a log file, but I want a log file that is a dependency of a module that is part of a build named Debian app with the number 1. What it means here, I'm not looking for the build that generated this file, but for the build or for the dependency that is included in this build. I know my build and I want to find the dependency. And as before, what I can do is first to use the CLI to run a search command. And with no surprise, here I can find my log file. So here it's stored in my Artifactory. I can see this is the one I'm consistent with the previous example. I can see that this Conan log file has been generated by the build product master with build number 7. If you remember, this is what I was looking for on the log file itself. So I'm consistent. And so now what I can do is to download it, run the Conan install command, and try it. So here with the CLI RT download using the file spec, I got the file. And now I will run a Conan install command. You can see it worked, and now I will just give a try to the application to see if it works. And it worked. So it was just to show you how you can navigate through the metadata and the importance of metadata. I will just stop sharing this, and I will share again my screen. But now I will go in my Artifactory. Okay, so let's go to Artifactory. Here it is. And I'm going to start with the Artifactories that were used for the entire lab. So here is that Artifactory. I'm on what we call the package viewer. I can see my Debian application, the different Conan packages sent to my Artifactory. And so here, if I go in my builds, I can see the build Debian app with build number 1. This is what I was working on with my AQL and my file spec. So what I did with my AQL was to find, regarding this build name, with this build number, I wanted to find the module that contain a dependency, and I wanted to find this dependency. So here is a log file I was looking for with my file spec, and this is what I downloaded. So here you can find the dependency ID, so the log file that I will use as a dependency to generate my Debian package. Okay, you can see that this Debian package, and this was part of the Conan Days training. So this Debian package has been promoted in a Debian UAT local repository, and so I can navigate to it here in my Debian repository, see the Debian information. Here I have the build part where I can see who has produced this Debian package, and I can navigate back to the build itself, and then go to the log file, that is a dependency. And here I can see it and see also that it has been used only by this build. So this is what I wanted to show you in the command line. With pure REST API, I was able to navigate back and forth to dependencies, generated packages, and so on. And I have this traceability, and thanks to the log file, I have also this immutability of my Conan build. Now, I mentioned a bit about advanced repository features, and what we didn't show you during Conan Days was some interesting things regarding the repository. Here, if I look at repository structure in my Artifactory, so I can find the different local repositories I used for my labs. So here I have the app Debian UAT local, where is my promoted Debian package. I have the Conan develop used by my developers, the Conan local, where is my final project package, the Conan metadata for my log files, and so on. What is interesting also is that you can see here in the last column of this view, there is a replication column. And if I have a look, let's say, to the Conan metadata repository, in the replication tab, I can see that this repository is configured to replicate all its binaries every day at 1 p.m. to 2 different targets. In fact, 2 different Conan metadata local repositories, but located in 2 different Artifactories. And what is interesting is that any delete, change of metadata, deploy, write operation done on this repository, my Conan metadata repository, will trigger the replication, and this replication, this sync, will be done on the 2 different targets. What does it mean? It means that if I go now on one of those targets, let's say this one, which is a different Artifactory, and okay, I didn't log in. Okay, if I log in, okay. So here I'm connected to an Artifactory that is running in Sunnyvale, and you can see on my map. So this is a map provided by JFrog Mission Control. I'm connected from Sunnyvale. Here I have the other Artifactory where I replicated my packages in Europe, in St. Petersburg. But what is interesting here is that if I look at the package view here, I will find different packages because this is used by different teams. But if I filter on Conan, here I will find all the Conan packages produced from the other data center, pushed in this Artifactory, and sync to my US site. What does it mean? It means that if an engineer in the US site now run the same AQL statement, the same file spec, and the same Conan install command as I run on my own data center, he will get the same result. He would get the same Conan package. He can consume the same Debian package because it's also replicated. So here, if I have a look to the Debian package, no, okay, it's not indexed. But here I can see that I have the same build. I have the same build information, the same metadata, and and I have my my Debian package also deployed on my Artifactory. So what it means, if I go back to my map, I have some developers working on the feature branch in Toulouse. This is where I live. After pushing to their Git repository, this has generated the product package, Conan package, after merging the change. And based on Artifactory replication, because I'm using it, all the metadata, all the binaries are synced to the distant sites, which means that now my developers, local developers on each site can consume their package from their local instance, their local Conan repository. And this can be applied to their Debian packages, Docker images, Helm charts, and so on. Okay. So I will stop sharing for now and go back to the slides. Okay. So what's next? First of all, I really encourage you to have a look to the next Conan Day edition and to the training. It was pretty hard to show you all the things I wanted in a single hour. So really have a look to it. Then you can go on our website to ask for a trial. We have also an Artifactory Community Edition if you want to start only with Conan. But if you want to start with more packages and advanced features, you can have a look to the trial. For 30 days, it's free. Go to our documentation page. We have a JFrog Academy with a lot of video content and training materials. And stay tuned. We have other webinars coming, white papers, and so on.